campus anyway. So let me go over just a couple of issues, nothing too serious, but somewhat. All right, here's, yes, got it. Okay. All right, no one else come in since I called roll. Okay. I haven't seen that they've asked for, what do they call it, midterm progress reports yet. But if they do, then I have to report, or we have to report anyone who is a D or an F at midterm. Now, this class has a good number of students, not half, but a good number, better than most classes, of getting research papers in, which have been pretty good scores, by and large. And you've been very good about getting the first quiz in, but I'm still missing several. And then, of course, you're not supposed to take the first test until you turn in the first quiz, so everybody who hasn't done the first test, had to turn in the first quiz, should not have done the first test yet, and then there's some others who weren't here to even do the first test who did turn in the quiz. So I'm missing some scores. Now, I'm preaching to the choir here. Y'all are typically the ones who have everything up to date, and you're in pretty good shape as far as scores go. But I'm saying this mostly for that. That's why I wanted to have the recorder on. Please, if you haven't gotten some type of a score into me, preferably the quiz, the paper, tests, I need something in, or else I'm going to have to send them that you have an F at midterm, which isn't going to really hurt anything, but it may just get you bugged to, do you need counseling, do you need tutoring, what can you do to help you improve your performance, that kind of stuff coming from the administration somewhere. So please try to get things caught up, okay? Because the quiz has been out there several weeks, and the test has been more than a week now, so please try to get some scores in. Okay, that being said, I will not be on campus at all tomorrow, either campus. Most Fridays I'm on the Birmingham West campus from 8 to 12, usually there before 8, usually there well after 12, but those are officially my office hours there. I have supposed to be going to Mobile tomorrow. It's an articulation meeting, a statewide meeting that I've been assigned to attend for math of the two-year college system. So I'm supposed to be there, but I turned in the paperwork last week and still don't have permission to have a car. Okay, so they said they have one reserved for me, but they can't do it until someone signs it, and it's been on someone's desk for almost a week now, and still well, I don't know. It's lost in the sauce somewhere, so I assume I'll be going, but if they don't provide the transportation and I don't have permission to drive my own vehicle, then I don't know if I'm allowed to go or not. So if I'm not allowed to go, I will be on the Birmingham campus tomorrow. But I assume they'll get it straightened out this morning so I can get the car and go tomorrow. I'll be leaving probably before 7 in the morning from home, driving 4 to 5 hours to Mobile, attending a 3.5 hour meeting, and then driving back and probably get home around 8 tomorrow evening. So it's going to be a long day, a lot of driving for 3.5 hour meeting. So not be on campus at all tomorrow. Next Friday, I also won't be on campus at 8 in the morning because I have an eye appointment right across the street here at the Birmingham West Hospital, UAB West Hospital, the eye clinic there, and I've got an appointment there at 8:15. So I'll come to this campus, be here before 8, hopefully, go over there by 8:15, and then when that's over, probably head back to Birmingham if I can drive with whatever they do to my eyes. I think I'll be able to. So, any questions before we get going today? All right, where we left off last time, we had done this slide, I'm pretty sure. This was the top of the page 118. We know how to find x-intercepts of a graph. X-intercept is where y is equal to 0. What's y? F of x, set the quadratic function equal to 0. If you can factor, find your zeros that way. If you cannot factor, use the quadratic formula, and that will give you the x-intercepts. Okay? Now, and we talked about last time, not all parabolas will have x-intercepts. A lot of them will have 2, no more than 2, ever, no more than 2. They could have 1 if it comes down and just kisses the x-axis at one place, or if it's elevated or below the x-axis and opening the other direction, it'll have no intercept. So remember, that may be the situation. Now, examples 3 and 4 illustrate this, but they skip those. So I'm going back to find, here's a good place to do example 3 and 4. Now, any questions before we get started? All right. Example 3. Sketch the graph of, I'm going to write the function up here to give me more room. F of x is equal to, can you all see it up there, okay? Negative x squared. No, I don't need it up there. That won't work well because I need to operate on it. So let me put it down here. F of x is equal to negative x squared plus 6x minus 8, okay, and identify the vertex and the x-intercepts if there are any. Okay. Is it? Huh? Yeah, Kiara. That's what I was going to say. Okay. Good deal. Thank you. Oh, okay, gotcha. Okay. Now. Okay. Anyone else come in since I called roll? What I think I'll do is keep from bothering people up and down the hall, close this door. That always ensures more people will come in. Okay. Okay, my question to you is, how do we approach a problem like this? They said, sketch the graph and be sure to indicate the vertex and the x-intercepts. So how would you want to sketch? You have a couple of options, by the way. Okay? One is the good old t-table, pick an x, calculate the f of x, which is your y. That's sort of the straightforward, grunt through it work. It's not the easiest way. I like the easiest way. What would that be? First step. Anybody? I knew as soon as I closed the door, someone would be here. So Asia is here. Thank you. Now finding you. There you are. Okay. Say again? Okay, we want to get it into standard form. And what will that, you want me to write down what that'll look like? You tell me. What will that look like? F of x equal to standard form. Very generic. A times x minus h squared plus k. That's your standard form. And you're already here, so I already got you marked. Okay. Very good. And what would be the first thing we would need to do to move it towards standard form? Anyone remember? I know it was 2 days ago, a long time. So what would we do in standard form? First step. What's the first thing you see here? A. Okay. What would be the A in this problem? -1. Perfect. Factor out the A. So this will be a minus, if I can get my pen to write for some, oh, the pen has just decided to stop writing. There we go. And then wrote double. Okay. So what it's doing, I'm not sure. Okay. thought someone was at the door, but I guess it just clicked. So we factor out the minus sign. Out of what? Again, think back to last time. Out of the whole thing? No, just the x terms, the terms with x in it. So what would that leave you? X squared minus 6x, then a big old blank, and then the minus 8. Now you can stop and check and see this is exactly what we have here, it's just written differently. Minus x squared plus 6x minus 8. Nothing's changed except how it looks. Okay? Why did we do a big blank there? What goes there? All right. Here's Carla. Gives you time to think. Okay. Why did we do that? What's our next step?
6 divided by 2.
Second?
6 divided by 2 and square.
Okay. Divide the linear coefficient, negative 6, by 2, and what does that give you? Negative 3. Okay, now here's what I do usually. I copy down exactly what we have here. I know this is going to be an x here, and as soon as you say negative 3, half of that, I'm going to write it down here. Because that's what's going to go there, that's going to be squared, and we're going to go from there. Okay? So, once you take half of that, so negative 3, what do you do with it? Square it. And what's negative 3 squared? Plus 9. Okay. Now we've just changed the problem. It's no longer the same problem we had before. We have just sort of felt like we added 9 to it, but you realize there was a minus sign here, which means we put a negative 9 in here. If you put a negative 9, what must you do out here? A positive 9. So you do not change the problem at all. Okay. So we've got that done. Now we're ready for the next step, which I've already started. The minus sign comes down, whatever the a is, okay? And I know the perfect square of this, the binomial square of this is a perfect square trinomial. That's what it's the perfect square of. As soon as you take half of this, write it down here. Once you have everything else in place. And then what else do we put? Plus 1. All right, because minus 8 plus 9 is plus 1. There we have our standard form. So what can you tell me? Ask for, identify the, what's the HK tell you? Okay. It's what? The vertex. So tell me what the vertex is. It's what? 3, 1. Perfect. Now, is there anything else you can tell me about how the graph of this is going to look? You know the vertex. That's a very important thing. Very good first step. Anything else you can tell me about how the graph is going to look? Why is it going to go up? What is positive? Okay. That doesn't mean anything about which way it's going. What determines that is the sign of A. What's A sign? Minus. So this is going downward. Okay? This one's going down. So when I go to draw my graph, which is the next thing I'm going to do, no, I'm not going to do it next. I'm going to do the other thing. What's the other thing it said to find? Okay, remember, I don't know what happened to my line. Oh, I know what to do. It's what? X-intercepts. How do we find that? Say again? Okay, this first thing? Okay. What I'm going to do is, because I really don't like, okay, what do you do with that?
The vertex, we can take
Yeah, okay, what about the vertex?
We can take x equals 3.
Okay, he's identifying the axis of symmetry. The axis of symmetry is x equal 3. You're absolutely right. That's the axis of symmetry. I thought you were saying x-intercepts. I misunderstood. My hearing's so bad. How do we find the x-intercepts? Anybody? So I'll be looking it up on your phone, so good. Hopefully you'll find an answer. How do you find the x-intercepts? Second? Okay. Before you factor, use x-intercept is where what is equal to what? Y is equal to 0. What's your y? F of x, that equal to 0. So that's the next thing we do. This is not the function. This is finding the x-intercepts. It's where the y is equal to 0. Now, here's something I do not like. I do not like trying to factor with the leading term negative. It's doable, but I don't like doing it. Okay? Once you get it into this equation, you can multiply or divide the same thing by both sides of the equation anything you want to. Except don't multiply or divide by 0, ever. Just don't do that. Okay? And what might you choose to multiply or divide by? The -1. So it's going to be the same intercepts. It's not the same function anymore, but who cares? The intercepts will be the same. So I'm going to rewrite this as x squared, you tell me, minus 6x plus 8 is equal 0. I just multiplied or divided everything on both sides by -1. With an equation, that's a legal move. Okay, now I want to factor. If it's factorable, you tell me if it is. Well, if it is, how does that first term factor? X times x. Okay, we got that one down. If it's factorable. Okay? Now, where do we look next? The sign of the last term. What is it? What does that tell you about these two signs? They've got to be the same. And what sign do they need to be? Minus, because that middle one's minus. So these are going to be a minus and a minus. Now we're looking for two numbers who multiply to be 8 and add to be 6. Now the reason I say add, the signs are the same. So they add to be 6. Two numbers that multiply to be 8, add to be 6. 4 and 2, that might work. Okay? 4 and 2. Okay? And what does that tell you? Second. Okay, x equal 4 will be 1. X equal 4. X is always equal to x, but this time it's equal to 4. Okay. X equal 4 or x equal 2. Okay? And by the way, this is so aggravating. Well, that's not aggravating. I mean, it gets here. Okay. So, there we go. I've got a question for you before you leave, so don't leave without checking with me. Okay. Now, what are these? X-intercepts. Actually, they're not. These are just numbers. To make an x-intercept, you need an ordered pair, and what would that be? 4, 0, because the y is 0. That's what we did. We set y equals 0 or 2, 0. So those are our two x-intercepts. There's our vertex. We're ready to go to town, aren't we? Okay? Axis of symmetry 3, x equal 3. I think we're ready to plot. The trouble is we just don't have a lot of room. So I'm going to plot right down the middle of this thing. And because, which way is it opening? Downward, this has got to be the top point, maximum point. So I don't need my much room up here because I don't need to go any higher than 1. So I'm just going to use this line right here that I already have here to be my x-axis. So let's just put in a few points. 1, 2, 3, 4, 5, 6, 7. We won't need that many. Negative 1, 2, 3, 4, 5, 6, 7. Won't need that many. 1, 2, 3, 4. We won't need that many. 1, 2, 3, 4, 5, 6, We're going to need a lot more than that. Okay. So, you tell me where to begin to plot our graph. Can I do it in a different color just because it's going to be hard to see on this? Oh, there's Q. Came in just in time to pick a color. What color you want? Green. Okay. Light or dark? Light green. Oh, okay. Let's hope we can see it. Okay. What's the first point we can pick? What? Yeah. It doesn't matter, but we'll go with 3, 1. How do I plot that one? 3 to the right and 1 up. Okay, good deal. Can you see it? Or would it need to be the darker green? Is that okay? Or you want darker? Darker. Okay, sorry about that. I'll let you choose, but then I changed. Okay. That's a little darker. Okay. Now, what other points can we plot? Ah, the 4, 0. How do I plot that one? Go which way? 4 to the right, and don't go up or down, right on the x-axis. That's what I call it, x-intercept. And 2, 0, same thing. Go 2 to the right and do there. And by the way, I forgot to plot this one. And it isn't really a point, but I'm going to change my color here and make it red because I like to do this in red. Okay, this is my axis of symmetry is x equal 3. So all up and down that line, x is equal to 3. And sure enough, these 2 points are symmetrical about the axis of symmetry. That's why we call it the axis of symmetry. Okay? Now, they have picked, or we have chosen 3 points and the axis of symmetry. And let's get another point. Now, usually what I like to do, you don't have to do it this way, this is my preference. I like to start with the vertex and go right or left 1, but we've already got those. Those are done. So let's go either right 2 from the vertex or left 2 from the vertex. I don't care. You pick. Right or left? Right. Right? Okay. Right 2 from the vertex will be, this was 3, 1, that would be 4, 5. So when we get a 5 here, x equal 5, let's go to this form. After you do your x-intercept, this is the form for x-intercept. Oh, there's one other really easy point. I forgot to say what it was. What is that? Before we leave this. 0 minus 8, the y-intercept. The trouble is, it's off scale, okay? Because when you put x equals 0, y or f of x is equal to f of 0 is equal to minus 8. There's 1, 2, 3, 4, 5, 6. If I'd have been planning ahead, I'd had it a little higher, would have gotten 8 in there. Can't quite get there, okay? But it's always a good one to check. So, you chose 5, so let's go to this form now. This form's great for your x-intercepts. This form's really great for your y-intercept, but this form's easier to do the calculations. So when you put 5 in here, 5 minus 3, 2 squared is 4, negate, minus 4, right? And then add 1, minus 3. Perfect. So when x equals 5, y is equal to minus 3. 1, 2, 3. That's right about there. Okay? Now, do we need to plot another one, or can you draw it? Go across the axis of symmetry. We're 2 to the right. Let's go 2 to the left, and you're right there again. You don't need to calculate another point. All you have to do is go across the axis of symmetry, 2 here, 2 there. That's what the axis of symmetry is. It's symmetric on either side. Want to try another? You want to go right or left from 2, 3 spaces? We've already done that. 3 here is going to put us at minus 8. That one's going to be minus 8. We're not going to be able to plot those, so we can just draw our parabola now. Whoops. It's going down like that and going down like that. Okay? There it is. What did they ask us to do? Sketch the graph. There it is in green. Green graph. Green, they say, on the far side of the hill. Okay. The vertex we found. The x-intercepts we found. We found the axis of symmetry without them asking us to. It was right there for the picking. Easy pickings. Any question? Make sense? Now, the book does it a slightly different way, which is fine too. They say, well, this, the parent function of this would be minus x squared. Okay? And then what did they do? They shifted 3 to the right and up 1. That's how they found their vertex. It gets you the same way. And just move the whole thing. A rigid translation, that works as well. Doesn't work quite as well if there's a coefficient there, then you have the stretching to do, but if you plot that one, you're fine. All right, and Dion just came in. If I can find you, there you are. Okay, good deal. All right, anyone else come in while I wasn't looking? Or while I was looking, okay. So no more questions on example 3. Just finished that. And we got pretty much the same thing they did. Maybe their picture's not quite as pretty as ours, but close. Okay. Any questions? Let's clear the screen and move on to example 4. Ha! Oh, and by the way, every example they give in the text also comes with a checkpoint that you can do, I would say, as soon as possible out of class, once you're out of class. Just so you can do something very similar while it's fresh on your mind. All right, this time example 4 says we want to write the standard form, we did that before, of a quadratic function whose graph is a parabola. Oh, what a surprise. Every quadratic function, the graph is a parabola. But it's a parabola with vertex 1, 2, and passes through the point 3, negative 6. Okay. We want to write this in standard form. They're saying nothing about drawing the graph. They're going to draw the graph. I guarantee you they will. They love drawing graphs. But all they're asking is, what is the standard form of that parabola? Do you have enough information to get it? Probably. Let's try. First, tell me what the standard form is. Yes. F of x equal a times x minus h in parentheses squared plus k. Okay, now wait. What in the world is h and what in the world is k? Oh, that's a vertex, and they gave us a vertex, didn't it? So we can write down 2/3 of this standard form right now. That would be a, we don't know a yet, times x minus, I'm stuck, 1, okay, squared, plus 2. You've done it. You got 2/3 of the answer right there. What we don't know is what the a is. Nor have we used this point. So can we use this point to help us find out what a is? What does that point stand for? What are those numbers? And let me ask this question. What is f of x anyway? Y. Oh, that's good. Y. Okay. Now, what do these two numbers represent? That really represents an x and a y, don't we? With x being 3 and y being negative 6. There's a y, there's an x. If we plug those numbers in here, we can calculate a, can't we? Right there, okay? So let's do it. Y is negative 6 is equal to a times 3 minus 1 squared. Now my pen's not writing. Come on, there we come. 2 squared plus 2. Okay, yeah. I was going to say, I looked at the wrong point up there, so that's not right. Okay, got it. No, that's not 3 minus 1. Yeah, that's right. I'm all lost here. Okay, so let's do the math. Oh, isn't that nice? Minus 6 is equal to, what's the coefficient? 3 minus 1? 2 squared. So that would be 4a plus 2. Now what? Second? We're trying to figure out what a is. Solve for a. So what do you say? Subtract 2 from both sides. And what does that give us? Negative 8 equal 4 times a. Hey, we're getting close. A is equal to negative 2. Divide both sides by 4. Okay, a is equal to negative 2. Now we go back to this, and I'll go back to f of x, so it'll look like a function. F of x is equal to negative 2 times, second, x minus 1 squared plus 2. There, we got it in standard form. Knocked it out. That's exactly all they were asking for. Can you tell me a little bit of how that graph is going to look? You know they're going graphic. So how is it going to look? It's what? Going downward because the coefficient, the a is negative. Okay? It's one thing about it. We know where it starts at the vertex. And we know it goes a little more quickly down because of the 2 there. Vertical stretch. Okay? And I'm going to try to do it quickly here. Okay? The vertex is at 1, 2, and we know the point of 3, oh, and by the way, the axis of symmetry has to go through x equal 1, right? So there's the axis of symmetry. We know that the line 3, negative 6 needs to be on it. So that's 1, 2, 3, negative 6. 1, 2, 3, 4, 5, 6. So this point is on it. Really easy. Well, no, not as easy here. But it's not bad. Setting x equals 0, what does this become? X equals 0. What does that become? 0 minus 1. Negative 1. Squared becomes 1 times negative 2 becomes negative 2 plus 2 becomes 0. Okay. So we started with 0, wound up with 0. Okay. So when x equals 0, y is equal to 0. Hey, there's another point right there. But if that's a point, then right over here is a point. Okay. What's the point? Oh, and I forgot this one. If 3, negative 6 is a point, what's another one? Oops, I'm sorry. Go 3. This I didn't draw my line in here. Yeah, I did. You go 2 to the right, 2. That's 1, 2. And there's another minus 6. There's our graph. Really easy to plot. Using the axis of symmetry. Okay? It was easy. They gave us this point. We know that has to be on. As soon as we know this point, we could have drawn that point. Axis of symmetry. Then we calculated x equals 0, y is equal to 0. Then we go across the axis of symmetry, and there's that point. After that, it's off scale. There we have it. Vertical stretch, inverted, because the a is negative. There we have it. Make sense? You weren't asked to graph it. They just graphed it to show, so sure enough, it works. There's a checkpoint there as well. Any questions? So if they give you an equation, you can get it in standard form and draw the graph. If they tell you 2 things about it, the vertex and some other point, you can get the equation in standard form. And then if you need to, you can graph it as well. All right. Any questions? Need to leave it up there a little longer? Everybody got it? Okay. All right, now we're going to find minimum and maximum values. Guess what? With quadratic equations, that's a pretty easy piece of cake. Because guess what? You either have one max or one min. And what is that point? Your vertex. Yeah. With a quadratic, a parabola, the max is going to be here or the min is going to be there. One or the other, no way around it. So this isn't a really hard thing to do here. Many applications involve finding the maximum and minimum values of a quadratic function. Now, there's no guarantee it's going to be a quadratic function, but quite often things can be modeled as a quadratic function. Are any of you ever planning to go into business? Okay, you are. Do you think you might ever want to maximize your profit? I would think so. That's one of the whole purposes of being there. Or minimize your cost. Hey, another good thing to do. So quite often we're interested in finding a max or a minimum. Okay? You may be in some other field, maximizing patient outcome or minimizing damage to the patient. Yeah, it could be anything. By completing the square of a quadratic function, okay, that's what we did to find the vertex, right? I mean, to find our standard form. You can rewrite the function in standard form. Now, this is doing it without any letters there, okay? By completing the square of this without any letters. It's doing the same thing we just did, but now we're going to do it with no numbers, just using letters. Oh, don't you love this? Isn't it so much fun? Okay?
So that's the same thing as the other.
Yeah, but let's go through it and do it. They just said, here it is. How do we start? What was our first step? Where did that go? Okay. Factor out the a, right? And that leaves us with an x squared. Now, here's the problem. Factoring is the same as dividing, right? So this second term becomes a plus b over a times x. Then's our blank and our plus c. Okay. Now, if you don't believe me, multiply through and see. A times x squared is ax squared. Right there. Okay? A times b over a is b times x. There it is, and there's your plus c. So yeah, that's right. Okay, what's the next step? Divide that linear term by 2. Dividing that by 2 becomes b over 2a. And what did I tell you could do then? F of x is equal to a times, you know this is going to wind up being an x, and that's going to be a plus b over 2a. You know that's going to be in there, and that thing's going to be squared. Okay? So once you take half of this, write that down. But once you take half of this, then what do you do with that? Square it. So that would then be a plus b squared, now it's b over 2a, over 4a squared. All right. Took half of this and squared it. But you've just added something to the problem, right? You added a b squared over 4a squared here, but you multiplied it by a. So when you multiply by a, one of these a's goes out, and you have a b squared over 4a. Okay? Well, let's subtract that from the other side. Minus b squared over 4a. Okay? So now we'll write that down. Plus c minus b squared over 4a. Okay? Now, what we just did is exactly what they did. A times x plus b over 2a squared, yes, plus c minus b over 4a. I like it better with numbers. I mean, we're doing the same thing before anyway. But this is where we stop for a moment. Okay? Right here, this is for a generic form. Whatever your A, B, and C is here. Notice what we've got. We've got the x component of our vertex right there. It'll be a minus b over 2a. Isn't it? Remember minus because you have to change the sign of this. Minus b over 2a. So guess what, folks? From now on, when you look at this, all you have to do is minus b over 2 times a that's going to be X component. You don't have to go through this anymore. You don't have to at all. Now, this would be a little harder to get the K component. Guess what? You don't have to do that either. Just take that X, which is minus B over 2A, calculate what it is, plug that in here, and then you can get what the K is right here. That will be your Y value and X equal that. So this just gave you, and I'll go to the next slide, it just gave you the X component of the vertex, minus B over 2A. You don't, okay, I don't want to say this, but I cut close. You don't have to complete the squares anymore. You can just do minus B over 2A as the X, and then plug that into the function, and calculate what it is. There's your K. Okay? So, this implies the following. Consider the function f of x equal a, x squared plus bx plus c. Standard, not standard form, but the way we usually write a quadratic expression, right? As soon as you see this, you can do minus b over 2a, and that tells you your h, the x component of the vertex. Okay? Without completing the square, you know it's that, because we just did it. Okay? Then plug that number, whatever number that turns out being, plug it in for that x and that x, calculate, that gives you your k. Right there. Now, you know if this a is negative, what you know about, or positive, that's going to be a minimum value because that vertex is going to be at the bottom. Okay? And the minimum value will be whatever the k is, right? The f of that. If a is negative, though, just from looking at the problem, that's the same a as the one elsewhere. You know, that same a. If this is negative, then you know that vertex is going to be the maximum. Okay? And you know that the value of it, the k, is going to be the maximum value. And we locate it at x equals that, and the value will be the y, or the h. Now, I want to point something out to you. I know all of you, being great algebra students that you are, you know the quadratic formula by heart, right? Okay, yeah. Let's recite it for me. X is equal to, anybody? Minus b plus or minus the square root of b squared minus 4ac. Y'all are good, okay? All over 2a. Why did I bring that up again? Look at this. What's the first term of this? Minus b over 2a. Minus b over 2a. There it is. And then the plus or minus is where you go on either side of that for other values of x. But the minus b over 2a is your vertex, is the h of your vertex. And then these other things are where it goes out to that. And it plus or minus means some on the plus side, some on the minus side. Okay? Yeah, that's exactly. So if we just remember that, we could have gone straight to that. Not quite close. Okay. So minus b over 2a. That is your h. So guess what? Hey, I'm sorry, but you don't have to do any more completing the squares if you don't want to. You got it. Just do h equal minus b over 2a. So let's do a problem with it. And so sorry that our baseball guys they must have a game today because they're not here. Example 5, path of a baseball. Okay, but y'all can do it now. They know what the answer is. No, I'm just kidding. Okay, after being hit is given by this function. F of x is equal to minus 0.0032 x squared plus x plus 3. Where f of x is the height of the baseball in feet, and x is the horizontal distance from home plate, also in feet. So the question is, what's the maximum height of the baseball? Okay? Now, don't you really want to complete the square on this one? Wouldn't that be a lot of fun? Factoring out this thing first, and then, oh, that would be so much fun. Hey. All right. Is it Tadarius? Okay. we're on Chapter 2, Polynomial and Rational Functions. We're in the polynomial part, 2.1, Quadratic Functions and Models, and we're in Example 5 on page 119, which is this one. Okay. So, if this is the path of the baseball, what kind of function is that? Quadratic. So what's going to be the shape of that graph? A parabola. So the maximum height is going to be at the vertex. Okay? So if we can determine the vertex, we can answer the question. Now, I know Carla wants to complete the square. Okay? I don't. It's too much work for me. But she's a hard worker and she wants to complete. I don't want to. How can we get that vertex without completing the square? The h is equal to, what did we just say? Minus, I'll start the first part, b over 2a. Hey, do we know what a, b, and c are? We don't even need c, but what's the a? Negative 0.0032, one of my favorite numbers of all time, okay? What's the b? Let's see. B is 1 and c is 3. Maybe we do need the c in there. Reminds us that's the 3, not the 1. Okay, right. Okay, so now we just plug it in. Whoa, get out of there. Okay, so this will be a minus b, which is 1 over 2 times negative, get out of there, okay, 0.0032. All right, so that would be negative 1 over minus 0.0064. Okay, now looking at that, I see a minus and a minus. Two minuses make a plus, which is a very good thing, that the h is going to be somewhere in front of you, not behind you. Otherwise, this guy has just hit an enormously powerful foul ball behind him. Okay, that's a strike. Okay, but this is going ahead of him, so we're okay. And what would that be? You might need to pull out your calculator to do that one. I don't know. 1 divided by 0.0064. Get out of there. Anyone got one? So you want 156.25? Is that what you said? That would be feet. Now what does that tell you? Second? That's not the height. It's the h, but the h stands for your vertex, hk, which is the h part is the x part, and that's the horizontal distance from home plate. That's how far out there it is before it reaches the maximum height. So how do we get what the maximum height is? This is basically your x. Plug it in here. Calculate the y. That was the f of the thing. Really need a calculator for that one. If you got that still on the screen, what you do is square it and multiply it by a negative 0.0032. Then add this number back again, and then add 3 more. And what do you get? Okay, wait just a second. This is, wrong direction. Okay. Well, what we had here was a minus here, and when we multiplied that, became a minus. And minus divided by minus is plus. Yeah. That's how it became positive. Okay. So that became a positive this. Anyone do the math yet? Okay, we got K equal what? 81 point what? 125. And that would be feet. So that's the maximum height of that baseball. I think that'll still be in the Superdome, so I don't think it's hit the ceiling yet. So I think we're all right. Okay? See how we got it? The H is the X coordinate. Plug that into the function, and you get the Y coordinate. I started to write that down because I thought y'all were taking too long, but you got it done before I could write it. Okay? Okay. I'll go on and write it, finish writing it. 32 times 156.25 squared plus 156.25 plus 3. I know you probably aren't this interested in it, but where did this function come from? Well, notice we're in feet, and if you're in feet, you're in what they call the U.S. customary system of measuring things. So your acceleration due to gravity is feet per second squared. That happens to be 32 feet per second squared. Okay? Now, I can't explain to you too much the other, why it becomes a decimal here. There is a reason, but the 32 comes from that. I'll tell you this. I'm guessing that the baseball was hit with an initial velocity of 100 feet per second. That would account for this. That would have been the velocity, but you divided by that squared, and that's what gave you that. And then the plus 3, if he hit the pitch and it's going that high and that far, he probably hit it right around waist level, right? He didn't hit it up here. That will, I don't think he can do that. It would be right about sweet spot right there, 3 feet. So that was the initial. When x equals 0, that was how high the pitch was, right when you hit 3 feet above the ground. Which makes sense. Okay, without our, and by the way, the book got the same answer. Good for them. There is a checkpoint right afterwards, and you can do that one. Any questions on this or others? Okay, that ends 2.1. Yes, okay, let's do the vocabulary. Linear, constant, and squaring functions are all examples of blank functions. Say again? No, if they were quadratic, they would have, okay, these are polynomial. They're all examples of polynomial functions. Squaring function would be quadratic, but linear and constant functions are not quadratic, but they are polynomials. Number 2, a polynomial function of x with degree n has the form of f of x equal a sub n, x to the n plus a sub n minus 1 times x to the n minus 1 plus blah, 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 up to a sub 1 x plus a sub 0. As long as a sub n, that first coefficient, is not equal to 0. Where n is a blank blank. What do your exponents, the n's are your exponents, what do they have to be? Say again? Okay, actually a little better, non-negative integers. Integers meaning they can't be fractions or decimals, non-negative meaning they can't be negatives. Okay, they have to be positive. Okay, but you see 0, it could be a 0, and the exponent for the is 0. Okay, so don't want to exclude 0. That's a big number. Okay. Okay, that's the first part. I've lost. Oh no, that's it. No, that's the first part. And a sub n minus 1, dot, 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 to a1, a0 are what numbers? Blank numbers. What do they have to be? The coefficients. They don't have to be integers. Obviously, that's an integer, that one's not. They are any real number. Any real number. Fraction, decimal, rational, irrational, just any real number. Okay, the coefficients. Exponents, non-negative integers. Coefficients, any real number. Number 3, a blank function is a second degree polynomial function. Quadratic, okay. And its graph is called a parabola. Got it. Number 4, when the graph of a quadratic function opens downward, the leading coefficient is blank, negative, and when it opens upward, no, I'm sorry. And the vertex of the graph, when it's Opening downward, the vertex of the graph is a maximum. Perfect. Okay, homework exercises. Do all of 5 through 8. Only the odd answers are in the back, 5 and 7, but you should be able to do all 4 of those. Okay? Then do any of the odds, 9, and by the way, they're both at Calc Chat. The odds are at Calc Chat. Okay, do any of the odds, either 9 or 11, they're both at Calc Chat, 9's at Calc View. Do any of the odds 13 to 25, they're all at Calc Chat, 17's at Calc View. Do any of the odds 27 to 33, they're all at Calc Chat. Do 35, it's at Calc Chat. Do any of the odds 37 to 45, now that's one like we did earlier today. All those are at Calc Chat, 37's at Calc View. Do either 47 or 49, they're both at Calc Chat. They say use technology here, but I bet you can do it without it. Do any of the odds 51 to 55, they should all be at Calc Chat. Do any of the odds 57 to 61, they're all at Calc Chat, 57's at Calc View. Do either 63 or 65 or both, they're both at Calc Chat. Do 67, that's an applied problem, that should be at Calc Chat. And then some more applied problems, 69 through 73. They should all be at Calc Chat. There's a true-false, 75. It should be at Calc Chat. You can think about doing 77 if you'd like, and 79 if you'd like. There is a proof 81 if you're into that. Go for that. Oh, we didn't show how they did their problem. Sorry about that. Let me go back and see how they did this problem. See if it varies any from what we did. Okay. From the quadratic function, they wrote that, the generic form down. We know, oh, they just wrote that as this. This implies that A is equal to negative 0.32. Negative 0.0032. B is equal to 1. Notice we don't need C at all. We identified it just so somebody wouldn't get it wrong. Okay, and but there's your A and B. Plug that into your function, negative B over 2A, and you found that to be negative 1 over 2 times negative 0.0032, and that became 156.25, which is exactly what you got. But that's how far it is from home plate. That's not the maximum height. How you get the maximum height was plug that in to your function, because that's what the function value, the y value, was how high it goes. And at that the maximum height at the distance that you found the maximum height to be, and this took a little bit of effort on the calculator. Please don't do, well, I mean, you can do it by hand if you want to, but so much easier with a calculator. 81.125 feet. That's way too much precision for what we've got as input, but that's okay. And that's the end of the 2.1. And we've already done the assignment, so let me see if we can get rid of that and go to 2.2. Okay. Any questions on 2.1? It's going to get here one of these days, I think. Maybe not. Nope, it's still trying. There it goes. PowerPoint is sort of slow. Okay. Let's go from current slide. There we go. All right. Just if you've been following, I think this was a picture that was in 2.1. This was the one in 2.1. The woman on the diving board. We're in 2.2 right now. Okay. Polynomial functions of higher degree. We've been dealing with degree 2. We're going to use transformations. They love transformations. The sketch graphs of polynomial functions. Now we're going to come up with a new test. Y'all like tests. I know that. I can tell from before. This is the leading coefficient test to determine the end behavior. What's happening in the long run, okay, of graphs of polynomial functions, okay? And then it says find and use the real zeros of polynomial functions in sketching aids, as sketching aids. So that's what we're gunning for We're going to do the leading coefficient test, tells us what happened in the long run for very large values, and then we're going to find real zeros. Oh, and one more thing, we'll use the intermediate value theorem to help find and locate real zeros of polynomial functions when they're not obvious. Okay, so let's start with, can you imagine, graphs of polynomial functions? This section will study the basic features of polynomial functions, like we haven't been doing that before. The first feature will be of the graph, and this is that every polynomial function actually has two features to it. We're going to talk about this first one first, then we're going to get to the next one. The first of these, all polynomial functions, when you graph them, are continuous. No places where you have gaps, holes, breaks, or anything else, you have a continuous function. No discontinuities, no holes in the graph, nothing like that. Okay? That's a sample of a graph of some polynomial function. Okay? See, it's continuous. There's another feature, I'll keep wanting to say it because I always say them together, but we'll get to them in a minute. Okay? This, is that a polynomial function? That graph? No, it can't be because it has a break in it. Okay? It has a discontinuity. Now, this piece over here could be a polynomial function, but this piece is probably a different polynomial function. May or may not be, but the thing is, they're not one polynomial function. That's a piecewise defined function, defined in two different pieces, not connected, not a polynomial function. Okay? Because it's not continuous. Polynomial functions have to be continuous. So we're not going to deal with these in this section. Okay? The second feature of a graph of a polynomial function is smooth. Okay? What that means, no matter how pointed this looks, it's never a point. It's always an arc. It's always a smooth curve. Never will you find a point. Never will you find a cusp. Never will you find a corner. Okay? It's always going to be smooth and continuous. See how smooth all these curves are. Never points. Smooth and continuous. Okay? So there's the second feature. Polynomial functions have graphs that are smooth, rounded turns, and they're always continuous. Smooth and continuous. All right. Any questions? All right. No sharp turns. Okay? Here's the absolute value function, one of our favorite functions of all time. Not a polynomial function because it has a sharp turn at the origin. Okay? Not smooth. Is continuous, but not smooth. So that's not a polynomial function. Okay? Now, the graphs of polynomial functions, this should be a new slide, but the graphs of polynomial functions of degree greater than 2 are more difficult to analyze than those of 0, degree 0. That's a constant function. Degree 1 is a linear function. Degree 2 is a quadratic function. Okay? We know those. Those are pretty easy. Greater than 2, going to be a little more difficult. Not hard, but a little more to do. Okay? However, using the features presented in this section, coupled with your knowledge of point plotting, which you know really well, intercepts, they work well, symmetry, that works well, you should be able to make reasonably accurate sketches by hand. The polynomial functions that have the simplest graphs are the monomial functions of this form, f of x equals x to the n. Now later you'll call these power functions. Okay? These are the sort of the parent functions of all your ones greater, where n is any integer greater than 0. Okay? If that n is 0, you have a constant function. If n is 1, that's just the identity function. If n is 2, that's your squaring function. Okay, on like that. So we're going to look at just these, what we called parent functions before. Okay. Here's when n is equal to 2. That's your squaring function. That's the little gray line here. Okay? When you jump up to n equal 4, it looks a lot like it, doesn't it? 3 points are always in common. The origin, 1, 1, and negative 1, 1. Make that a 6, and x is 6. Same 3 points. The only thing that changes They get flatter near 0 and steeper past plus or minus 1. It's just keep going like that. Soon you're almost got a square function, but you never do always round it. It just hangs around down here longer and goes up. Now, if the n is odd, like the cubic function, that's the gray function here, it goes up and goes like this. You go up to 5, it's almost the same. It goes through -1, -1, 0, 0, and 1, 1. Okay? It just hangs around the x-axis a little bit longer and goes up steeper past plus or minus 1. They're all going to look like that. All the evens are going to look like this. All the odds like that. They just get flatter near the origin. The higher the number is, steeper outside plus or minus 1. That's what we're going to look like. Seems like a lot of yada about not much. How are we doing? I can tell the natives are getting restless. Okay. Moreover, the greater the value of n, the flatter the graph is near the origin. I heard that somewhere recently. Okay. Now, I don't think we're going to have time to graph it, are we? So we will start here next time. Example 1. Now, somewhere here I brought a pencil. There it is. I don't think we got enough done to do any more homework exercises, so you're going to have to content yourself with the ones from 2.1. So we'll start at example 1 next time. Any questions? All right. Now, for those who haven't turned in the first quiz, I need those first quizzes in. And those people probably haven't done the first test either. Please do the first test. Today? What time? Now? Now? Okay. If that room is available, I can.
Still recording.
Oh, okay.
And you said you needed to talk to me.
Yeah. Okay, let me get this turned off. Not that it matters, but.